In this video we will learn how to solve polynomial inequalities. I will only be using method 1 in this video, where we will find the zeros of the function and use test values in each interval to find the solutions. And I will be heavily using my TI-30 XS multiview in this video. Problem number 1 is already factored for us, so we can go ahead and skip to the part where we set each factor equal to 0. So we get x equals 0, x plus 1 equals 0, x minus 1 equals 0, and x minus 3 is equal to 0. So that gives us x equals 0, and then x equals negative 1, x equals positive 1, and x equals positive 3. So these are the zeros of the function. We will take those zeros and use them to separate the number line into zones, which we will then have to test one by one. So let's see. The smallest value here is negative 1, and then we have 0, and then we have positive 1, and then we have 3. So now we need a test value in each zone to check. Actually, I almost forgot something. We need to plot these border points, these critical values, as dots. And sometimes they're open circles, sometimes they're closed circles. Well, these are the numbers for which the functions equal 0. Okay, so because to find them we pretended like the function was, see how we set everything equal to 0. So do we want to include those or not? Well, we want to know where the function is greater than or equal to 0. So the points that make the function equal to 0 should be included. So we're going to show that these points are included by writing them as closed circles. Okay, so we will put closed circles at each one of these critical values. So bottom line, if it's got the or equal to sign, then it will be a closed circle. If it had been just greater than, then we would have done open circles. Okay, anyway, we need test values, 1 in each zone. So something to the left of negative 1, I will try what's the value of the function at, say, negative 2. Now, between negative 1 and 0, we're going to need a decimal. For example, let's check the value of the function at negative 0.5. Now, between 0 and 1, again, we'll need a decimal. For example, positive 0.5. Between 1 and 3, we could use 2. And beyond 3, we could use a value of 4. So these would be good values to use. So let's test these values, and in each case, let's see whether or not the function is greater than or equal to 0 in that zone. So, time for the calculator. Let's type this function into the TI-30 XS multiview. So hit your table function and get to typing. Just going to move this over here. Okay, so we have x, and then x plus 1, and then x minus 1, and x minus 3. Okay. Now, to evaluate the function, I find it best to put the calculator into Ask X mode, so that I can tell it just exactly the x values that I want. So in ask mode, we can type in whatever values we want. So let's type in -2 and -0.5 and +0.5. So here's -2 and -0.5 and +0.5. Okay, so we get the y values that go with those x values. So let's see, we have 30, -1.3, and 0.93. Okay, I guess I could say 0.94 if I rounded properly, but that doesn't really matter that much in this context. In fact, let's just call it 0.9. So again, we are looking to see if if the value of the function is greater than or equal to 0. So is 30 greater than or equal to 0? Well, yes, it is. Is -1.3 greater than or equal to 0? Nope, that's a negative number. Is 0.9 greater than or equal to 0? Yes, it is. All positive numbers are greater than 0. Okay, so far so good. Now let's check our last values of 2 and 4. Alright, because the calculator will only do 3 at a time. So let's go back and do 2 and 4. And that gives us -6 and 60. So we have -6 and 60. Is -6 greater than or equal to 0? Nope. It is less than 0. Is 60 greater than or equal to 0? Yes, it is. Very much so. Alright, so all these yeses and nos are indicating where the solutions are. Since -2 turned out to be a solution to the inequality, that means all of the numbers in this interval will be solutions. So I will show that by drawing an arrow. So everywhere there's a yes, that's where the solutions are. Everywhere there's a no, there are no solutions, so we'll just leave it blank. And we have one more yes over here. So there you go. Alright, and in the end we need to record this in interval notation. So I'm going to have an interval for each one of these arrows and segments. So I'm going to wind up with 3 intervals in my answer. So for this arrow on the left, it goes from -infinity to -1. So I'm going to have -infinity to -1. Infinities always get the round, and this closed circle corresponds to a bracket. If it were an open circle, I would make it round to show that it was not included. And then we have 0 to 1. So we're just going to go bracket and from 0 to 1. And I'm going to put a union symbol in between to join these together because it's all part of one solution set. And then we have our final interval from 3 to +infinity. So I will go from 3 to +infinity, bracket, parentheses, and another union symbol between. And that's it for problem number 1. In problem number 2, we will follow the same procedure, but unlike problem number 1, it's not factored for us. So we will factor the problem ourselves. So we'll find the zeros of the function by factoring. So this would factor as x plus 5 times x minus 5. And we're finding the zeros, so I'm going to just go ahead and set that equal to 0. And that means we need to set x plus 5 equal to 0 and set x minus 5 equal to 0. And that will give us x equals -5 and x equals +5. These are our critical values, which I will graph on the number line. Notice that we want to know where the function is less than or equal to 0. So again, we're going to wind up using closed circles for these. So -5 and +5 on a number line. So here we go. So here's my number line. Here's -5 and here's +5. And we will graph them as closed circles. Alright, so now we need a test value in each zone that we have created. So over here to the left of -5, we could check out the value of the function at -6. You could use other values if you wanted to. Between -5 and +5 is 0, so I'll use 0. And beyond 5, I'll have a value of 6. So these will be my 3 test values. Alright, so I'm going to go ahead and put the function into my calculator and see what it looks like. So we're dealing with x squared minus 25. So x squared minus 25. Whoops. Did not hit the minus key. Alright. Again, I'm going to leave my calculator in ask mode as I do this. So the values that we want to check are -6, 0, and +6. Okay, so -6, 0, and +6. So we get values 11, -25, and 11. Okay, so 11, -25, and 11. So remember, we're trying to see whether or not the function is less than or equal to 0. Okay, so is 11 less than or equal to 0? No, 11 is greater than 0. Is -25 less than or equal to 0? Yes, it is. All negative numbers are less than 0. And we've already answered this question. Is 11 less than or equal to 0? No, it is not. So the yes tells us that this is a solution. 0 is a solution. So that means all of these points between -5 and 5 are solutions. So I will indicate them with a segment. And these no's on either side means there are no solutions less than -5 or greater than +5. So now we can just record this solution also as an interval from -5 to +5. So that would look like this. -5 to +5, bracket, bracket. These are closed circles, so we use the brackets instead of parentheses. And that's it. That's the answer for number 2.